Hey everybody, this is Larry. This is well, here it's September 2nd. It's actually before the new problem is up. So I am actually doing an algo problem that I haven't done yet. Yeah, just so that I could do an extra problem. Today is my rest day. Uh True real rest. In the past, I haven't had real rest days where my rest days were just going to strength training, and that's just tough. So yeah, but as marathon training is coming up, or ramping up rather, I'm giving myself more rest. I think one thing that I thought about, and I was actually talking about the contest videos, right? Like I do my daily videos on Leetcode. As if you're watching this, then you probably maybe see them. Hopefully, you hit the subscribe button so that you can do them with me every day, even if just to kind of compare notes and check answers, whatever, and check ideas. Even more importantly, right? Even maybe possibly easier problems. But yeah, I also do the other thing that I do is the contest videos, right? Where I do a contest, a live recording. I mean, obviously it's not live because that's cheating, but I record it live and then I push it out. So sometimes it's good, sometimes it's bad, just because it's live, right? And I was also doing an explanation video. I think one thing that I don't know. Maybe some parts of it is that these new contests, these recent contests lately, it's been too easy and too hard, or well, one easy, one medium, but two easier problems and two more difficult ones. And as a result, I think people, getting stuck at the Q3 more and more often, right? The easier of the more difficult ones. I think the thing is that. And this applies both for the Leetcode contest and also just like when you're practicing by yourself, right? Is that I don't know. I feel like there are two things, right? One thing that I always talk about, and I've mentioned this before, so I don't want to. At least today, I don't want it to be the focus, which is that understanding is not the same as being able to do it, right? Just because if I explain it in a way such that you understand it, you understand the solution. Is that good? Yeah, it's good. It's not bad. But what I try that's not necessarily what I'm trying to do, right? What I'm trying to do, even you could say maybe it works, maybe it doesn't. That's fair. Is that I'm trying to go over ways such that you can solve or you could get to the solution, right? The distinction about being able to solve it and or just understanding it, right? You could say maybe understanding is a prerequisite to solving it, but I don't know that that's necessarily true per se, in the sense that understanding the solution doesn't mean that taking the steps to get there are not quite the same thing, right? Anyway, and that being said, so that I've talked about this in more depth in the past, and the thing is that obviously the conclusion there is that your goal should be to focus on being able to solve it. And that's what I try to kind of explain it in my way, is that how I approach it, right? I think that's more interesting. For me, I consider it more interesting, or at least it's more me, right? Because anyone can read the solution. Yeah, a lot of people do. Some people make videos, right, where they clearly read solutions that other people wrote, and they weren't able to solve it, and then they just kind of be like, oh, this is the explanation, and then they sound very smart because they just kind of read it off some forum, or they copy someone's solution and have ChatGPT write up the explanation and be like, oh and maybe it flows a little bit better, maybe the understanding is a little bit easier, but at the end of the day, you still, okay, you tell yourself you're able to understand the problem or the solution, but you're not able to solve it, then what's the point, right? I don't know. I mean, maybe some people, and it works up to a point, right? Because it works because a lot of the easier problems, all you have to do is memorize enough that you're like, okay, let's do the same thing, right? But when you get to the more difficult problems, that doesn't work anymore, and that's why people get stuck. People get stuck. It's not because they're not able to understand it; it's because they're not able to do it, right? And doing it is much more difficult than understanding it. And that's why some of my videos are kind of tough, because I try to illustrate how to do it and how to get to the point where you can do it, and not just explain. I don't find any value in just explaining the solution, right, per se, or at least in a way that I'm hoping to kind of hit some points in which you're like, oh, this is what I have to do. This is what I have to do to get there. Not, oh, I understand. This is what I have to do to understand it. Right? Those are two distinct things. This is not a test. This is not like, on a college test or something where you're tested on your understanding. You're tested on your ability to do these things, right? Okay, so that's the one that you watch this YouTube's long enough. I've said it before, right? But the second point, also honestly, because the problems are getting more difficult now, is that and I don't know how much of it that I trust that, or how much of it I don't know how, like if your goal is for interviews, are interviews getting harder? I don't know that I see signs of that, honestly. I mean, maybe here and there you can say in India or something like that, in OA. I'm not going to get into that. It's just that's the way some things are set up. Then yeah, maybe, but I don't know. I haven't seen much of that, at least in the US, right? Your mileage may vary. Don't quote me on it. But in any case, Leetcode itself is getting more difficult, whether the interviews are getting more difficult or not, right? And I think there is a thing to be said, is that at the end of the day, and some of the comments that I get from YouTubes, and I don't care that much about it per se, because I'm living my life, I don't care that much about it. But well, two things, even from this. One is that, and I've said this other part before, which is that if you're leaving a comment to say that you don't understand something, that's useless to me and you, right? Like, what am I going to do? Explain it clearer? I mean, for the most part, I think I'm trying the best I can. So, like, there's no help to everybody. It's like me saying, hey, you didn't solve that problem. Why don't you just solve the problem better? Do you feel like that's good enough to help you solve the problem actually better? No, right? You'll just be like, Larry's being an idiot because he's like, damn, if I could solve the problem better, I would solve the problem better. So that's what it sounds like to me when you leave a Leetcode or when you leave a comment on YouTube. You're like, oh, you didn't explain it better. So if you're gonna ask a question, or if you're gonna leave a comment, or at least if you want to leave a comment that is useful for either you or me, one or the other, or hopefully both, but is ask a question that allows me to help you understand better, even if it's just understanding, right? Like if you make a statement and it doesn't change anything, then you're not doing anything, right? If you're asking a specific question, like, okay, like, and some of it needs to be self-aware, right? Like, I'm like, oh, I don't understand this thing that Larry said because he ran over too fast. Can you explain, like, what is the blah blah blah's principle or whatever? Or not even that. That's maybe not even terrible. Like, maybe more specific is, I don't understand this specific proof of this principle. How do you get from A to B? And then, that's a question I'll be like, oh yeah, you get from A to B because, oh yeah, I said this too fast. You do this by doing this, right? That's how you ask questions with an intent to understand. Yeah, maybe you're frustrated, maybe, I don't know, and that's maybe fair. And some, these things are hard to understand. More, if they're not hard, then you wouldn't be here watching my YouTubes, right? They're hard to understand and you're frustrated, but please, it's useless if you just say that, oh, you didn't understand it clearly. You didn't explain it clearly. And I could just say the same thing, right? And it's kind of mean when I say it. It's like, oh, you should just solve the problem better. Or you should understand better. Do you think anyone has helped? Anyway, that's not even what I meant to say. Whoops, what did I do? This intro is very long. But the other thing that I want to say is that I think for example, for Q3 of the weekly problem or weekly contest, the thing is that the problem was a bit mass dynamic programming problem. It's a problem. Maybe there's some argument that I need to do a video on it. I tried to make a video in the past, but someone gave me some crappy problems and I just got lazy about it to kind of test on it. But the point is that, okay, I said it in the video, you need your prerequisite is bit mass dynamic programming. I'm not going to go over it. And the thing is that I explained the rest of that video with the context in mind that you need to know about, you need to be pretty good at bit mass dynamic programming, right? And if you don't meet the prerequisites, you're not going to understand it. And, I don't know. Like, people still ask me about it. I'm like, I don't know. Like, I told you the prerequisites, right? And and I don't mean to say this to suggest to make anyone feel bad or anything. It's okay, right? It is just that one thing I would say is it's okay to come back later. Just because you saw a problem, you've seen a problem, you tried on a problem, does not mean you have to solve it today. It may mean that you don't have the ability to yet, right? And I would never say that you'll never be able to solve it, but just not today, right? Like if I go to the gym, I try to bench, my max one rep max. I try to bench it, and I just failed that day. I'm not going to be at the gym trying for hours until I get it, right? That doesn't make sense. My body's just not ready for it. And Leetcode or competitive programming is probably the same way, right? Even if you do get to a point where you understand the solution, you still maybe just not able to do it. That's fine, right? You get to, and that's the thing, right? Is that because there is this understanding component, I feel like a lot of people fool themselves into thinking that just when I understand the solution, I could do it. That's not true. I understand how to do a bench press. That doesn't mean I could do, a heavy weight, so something like that, right? So one thing is that it's okay to walk away, right? No one, you could be good at the things you want to be good at. You don't have to be good at training. Training is for training. Training is for being good in the future, right? So, it's okay to drop it and come back later. If you don't know bitmass dynamic programming and you're unable to solve the harder ones, then yeah, that's fine. I mean, you should solve easier bitmass dynamic programming problems and then work yourself up more difficult ones, right? I mean, I think when I said it that way, it makes sense. But yet, everyone's like, "Oh, I have to understand this. I have to understand this." I mean, no, like, and that's the end of the day. Is that you can understand something and still not solve it. So, what benefit are you getting from understanding it? I don't know, right? Anyway, so my point here on this last thing is that it's okay to skip ahead. Or not skip ahead, but just skip the problem and come back later when you have the prerequisite, when you have the foundations built, and when you have to have everything ready, right? There's no point of, wasting time on something that you're just not able to do, right? Yet, right? Because you don't have the foundation for it. You could come back for it. It's fine. I give you permission. It's okay. I do it all the time. Not in Leetcode, I don't think, but definitely in the past, the solutions and explanations are less available, so I would just come back after like a month and like, oh, can I solve this problem now, right? So yeah, I mean, it's okay. Like the literal, like this problem is 2892. The 3,000 problems, you can find a problem that you can solve. All right, just get your work in and focus a little bit better on what you want to do, and that's it. Okay. That's basically my point for the day. 14 minutes in. My apologies if you weren't expecting that and was just looking for a problem. But hopefully, if you do enjoy it, hit the subscribe button, hit the like button, and hit all those buttons. I mean, I don't know. I've been making these videos for like, I don't know, a very long time, right? I mean, even my streak is 1616, and that number doesn't even sound real. It is 1,616 day streak, right? So I've been doing this for 4 years now or something, right? Is that 4 years? Yeah. So like, so I've gotten slightly better over time and I've seen some patterns, but I don't know, it is what it is. All right. Anyway, let's take a look at this problem that I have not solved before. Oh man, I forgot that. Yeah. I'll cut. Yeah, okay. Let's solve this problem. Alright, 2892, minimizing array after replacing pairs with their product. Given an integer array nums and an integer k, you can perform the firing operation on the array any number of times. Select two adjacent elements of the array like x and y such that x times y is less than or equal to k. Replace both of them with a single element with values x times y. So, what's k? Okay. then return the minimum possible. So basically merge as much as you can, right? So where'd my soda go? Okay, never mind it. Let's see. The first thing I want to take a look is the constraints. The constraints are general enough that I guess we're supposed to find a user solution. And my first guess is that it's going to be some sort of sorting. Maybe not sorting per se, but like some kind of ordering, right? I mean, I think one thing that maybe this problem looks a little bit difficult in terms of proofs and stuff like that, and yeah, and there, I think one thing that people might kind of come across is that there are a lot of intuition and stuff like that, and you can maybe intuit something, but honestly, it's just with these things. It's tricky to get an intuition that you can also be confident about, right? With some greedy type solution. One thing that I would say is that if you are kind of thinking about these problems, the way that I would think about it is that with product, the thing is that multiplying two numbers is the same as adding the logarithmic of two numbers, right? And then now I think you can kind of see how the greedy solution would kind of work, right? Because log of 1 is 0 or something like this, right? Is that true? Did I make that up? Yeah, log of 1 is 0, right? So then now it becomes more apparent how to kind of, or maybe not more apparent, but at least you can kind of see how to kind of merge them, right? But it is still so tough to kind of prove anything. Like, I guess you're supposed to merge them at a time, but and ones don't really matter because they just disappear. Well, there's an edge case where all the other non-1 numbers. Oh, it could be a 0 even. If there's a 0, that's really easy, but I mean, yeah, okay. You can even write it out, right? If 0 is in nums, then we return 1, right? Because that means that, yeah, you just, unless k is also something funky. But no, then yeah, right? Otherwise, I mean, I guess it makes sense to kind of take the biggest number and then see what is the other biggest number that it can merge with, right? I think that makes sense, but it's still like very hard to prove. Alright. But it does remind me of another problem, but I think that problem oh wait, I messed up. I mean, I think this is still true, but this has to be a JSON. Okay. I actually missed this. I don't know why they do X and... okay, I guess X and Y just numbers. Yeah, I missed the JSON part. The JSON part makes it a bit trickier, right? So yeah. Yeah. Okay, so it's a JSON. Sorry, I have to like reset my brain because I was thinking. That's why I said my initial idea is sorting, right? Obviously now there's no sorting because of a JSON. I missed this part. Even though it's in bold, I just cannot read clearly. But okay, so what does this mean? I mean, it is going to be some sort of greedy, but I'm trying to figure out how, or maybe it is, I don't know, right? But like, do we want to minimize or maximize the thing, right? Like, okay, let me see, right? I mean, it's a decision of sort. So then you have like, two. Let's say k is equal to 20. I don't know. And then you have like 2, 2, 2, 2, 2. Then clearly you want to merge the 4 2s, and not the 2 and the 9. But what if you have like 9, right? Then how do you think about this, right? Is it just greedy, like merge as much as you can? Right? Like, is it? And then also, like, how would you, how would you get to it, right? This is definitely not an easy one. Huh. Though what I said about logarithmic is probably still true. So what would I do with its sum, right? And then there's another thing of like, okay, well, what if there's another 9 here? And now maybe it's less clear, because then now you can merge, instead of merging all the 2s into, what's it, 16? So then now you have 16, 9 thing. Then now you could do 9, 2, 2, 2, 2, 2, 9, right? I mean, I guess that it's still 3 numbers, but you could imagine there's like another case. I don't know, like there's a similar case where that just wouldn't necessarily work, right? I don't know. Like, it's not convincing for me. Okay. I mean, I think one way that I would think about it is dynamic programming. Whenever I see, I mean, I thought it was going to be greedy, but maybe I'm wrong, honestly. It is just that, if it's greedy, then maybe you could do something with O of n, right? And n is 10 to the 5th. And I think maybe I struggled too much, or like I tried too hard to abuse this. But the reason why I didn't think it was dynamic programming initially is because n is equal to 10 to the 5th. It is going to be a bad time, right? What I mean by that is that I know the answer now. But yeah, what I mean by that is that even like it's very hard to have an n log n dynamic programming, but obviously n squared dynamic programming is not going to be good enough. But there is this principle that we've been playing around with different contests lately, is that actually, so okay, so what would my states be, right? And I'm explaining this a little bit weird ordering, because I don't know, that's just the way I'm gonna, right? But maybe it'll become a little bit clear later, right? So index is going to be 1. It just always is going to be probably, right? Unless it's some weird thing. And then the second one is actually going to be the current multiplier, right? Or current product. Yeah, product, right? And the reason why this is, you take a look at this and you're like, well, this is impossibly big, right? Like, your first analysis will be index is going to be 0 to n, obviously, so that's going to be n. Product could be 0 to 10 to the 9, right? Not factorial, just very excited, right? So this is too big. But one thing that you have to keep in mind is that, and this is something that is kind of really tricky, honestly, but the only reason why I kind of have this idea is because we've seen it enough times on Leetcode. But otherwise, product is a product. And okay, yeah. So what does that mean, right? So that means that either previous number is 0, then we actually kind of cheat about this, right? Like, so there's no zeros and nums anymore, right? So yeah. So either that. So what does product mean, right? Product means that if you multiply a number, it becomes, what is the smallest number that you can multiply, right? Well, the answer is 1. But so 1 doesn't change the product. But what if the answer is 2? Well, if the answer is 2, that means that product is going to double, right? Well, how many times can it double? So from 10 to the 9, the max number of times it can double is 32 times. Or I think technically 30. I think it's 2. It's 10 to the 9th, not 2 times 10, or whatever, right? But about, right? So that means that given an index product pair, it can only have at most 30 unique products, right? Okay, and I'll draw it out really quickly in a sec. I'm bringing up the drawing board, right? And for now, we'll just skip ones because if you have 1 as the previous number, it skips forward anyway, right? I hope so. Otherwise, we can do some special thing to compress the ones. It's really not a big deal. We could actually remove the ones, I think. Now that I think about it, so we can pretend there are no ones. Like, I think it works with ones, but even if it doesn't, like for some implementation case, we could remove, for this problem, we can remove ones because that's a trivial merge, right? But in any case, that means that we have x, right? So we have some x, and then we have some previous number that is an x, so it's going to be 2, and the smallest number is going to be 2x, and then 3x, 4x going backwards, right? So that means that we have one unique number going into for a given index, and then going two rows deep or 2 index deep is going to be 2x, 3x, 4x, 5x, right? So that means that at most there could be only 32 distinct values coming in because it is x times some number, right? So that's basic before it goes over 4, I mean, you can say over 4, but it'll be bigger than k, right? I said 10 to the 9 because k can be up to 10 to the 9, but that's the basic idea. So okay, so that's basically how we're going to do it. Yeah, and then it becomes a lot easier. For this thing, we'll write a manual lookup cache, right? So lookup, we just have a lookup thing. We write key is equal to index product, or maybe we'll call it memos, right? So then if key is in memo, then we return memo key, right? So this is just this is me just writing the memorization template, right? So it doesn't matter, you know, this will look like this no matter what's inside, right? This is just regular memorization, dynamic programming, whatever you want to call it. So then now we have tick or no tick, right? So tick, no tick. So then we have to do a base case first, of course, which is that if index is equal to n, then we just return 0. Yeah. Because, and the other way to think about it is that when you merge, that means when you take a number, then you do not add a cost. And when you do remove a number, you do add a cost. You can also just like swap it, right? Because it's just n minus whatever it is. So it should be okay. So when we take, we continue this current sequence. So that means that, yeah. So get min, index plus 1, product times this particular number. Maybe we have to filter it, but yeah, in that, yeah, nums is equal to nums, or x for x in nums if x is greater than 1, or if it's not equal to 1, right? Maybe we'll do it after this thing, yeah. So then now it could be greater than 1, right? Because if it's 1, if it's 0, we will return it. If it's 1, we can take it out because it's a trivial merge, right? So then it's this. Or get min index plus 1. We start with the current number as the new new sequence, if you will, or new stack, right? And this plus 1, right? So then now we want to say best is equal to min, yeah, minimum of these two things. And yeah, and we just return best. And then here we can return get min 0 index, and I guess we start at 1. Yeah, okay. Well, actually, we just start at the index 1 with num sub 0 as the current product, and we start a new sequence, and I think that should be good. Ooh, wrong answer. Oh. Well, actually. I mean, I'm just being dumb. I don't have any if statements here, so it gets really big, right? So basically, best is equal to infinity, say. I was just being lazy. Okay, sorry. So okay, so then now if product times num sub index is less than or equal to k. I don't know why. That's such a critical point. I just forgot about it. My fault. Right. So then now best is equal to min best of this. Right. Otherwise, we always are good for no tech. Special. Yeah, we're always good for no tech. Right. So yeah. I just want. Yeah. I mean, it's fine. I was going to point out the case where num sub index is greater than k, but it can contain a number greater than k, it just cannot merge with anything. I think that's where the one filter is wrong, actually. So we can take this out. Now that I kind of think about it. Because basically, if k is equal to, say, 20, if you have 121, 121, 121, you cannot actually merge them, right? Even though, so I think that's like a weird edge case. So yeah, but yeah, up to 32 unique values, right? And like I said, this does not change if you have a 1 as a num sub index, so that should be fine. Okay, let's give it a spin. Yeah, looks good. Let's give a YOLO submit. Yeah, looks good. A little bit slower than expected, but you know, maybe there's stuff that we can do to skip ahead, right? Like I said, I think there's some edge cases that I took account of, like if it's equal to 1, it looks pretty sketch, but otherwise it should be okay. The memory's a little bit sketchy, maybe. I don't remember what the max is, but the time I'm not worried about. I mean, I kind of did this a little bit, whatever. But yeah. What is the complexity here, right? This is going to be O of n times 32 or log k for the number of bits. Yeah. Yeah. That's all I have with this one. I mean, I think this concept comes up from time to time, so, and I'm not gonna lie, I was not good at it, but I've seen this like 4 or 5 times now, right? So, yeah, the proof is pretty, you know, I think the hard part is saying that product has up to 32 unique values, and once you see that, it should be okay. I want to see if there's any, like, maybe a greedy solution that I missed. Maybe there is. Clearly there is. Okay, well, that's why my thing is so slow. But I don't know that I can prove this, though. Okay, then maybe I've done some crazy things. Apparently it is. I mean, I think that's the thing, right? Is that with this, I just couldn't figure out how to prove it. Like, why would you not? Oh, I see. So my case for why I couldn't understand it's greedy was this case where you do left to right and k is 0 to 20, then like, okay, why wouldn't you? But I guess the greedy idea is that well, if you go from left to right, if you don't take 9 and 2, then the 2 will go to the back, but then this means that this number is going to be strictly greater than this number, which leaves us, you know, so okay, I guess that greedy idea works. It's not quite the exchange argument, but it's the forced choice argument, I think, or whatever it's called. Well, I still, okay. I did it with DP, so I didn't have to deal with the proof, but yeah, I guess the proof makes sense. I don't know. That's all I have for this one. Let me know what you think. thanks for watching. Yeah, apparently do more greedy problems. And also, as I always said, even I struggle with greedy problems. So yeah, there you go. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.